Today we discuss important example of group. We known about group in previous class. We also that means known about definition, uniqueness of identity element, uniqueness of inverse element in previous class. And now today we discuss so many familiar examples. We start from this one. We define some addition operator, addition with respect to modulo n, this operator on Zn. Okay, so we discuss it. First we define how this addition modulo n happen between these classes. Okay, so we start it here. Class A, class B belongs to Zn, and class A addition modulo n, class B equal to class A plus B. Okay, so we discuss this one now, how this one is improved. We also now talk about that. So first prove that this one is a binary operation. For this, we let a class A, B, C, D belongs to Zn, and suppose class A equal to class C and class B equal to class D. Understood? Not a problem at all. Then this implies that, then this implies what? This implies n divide A difference C and n divides B difference D. Understood? I think not a problem at all. Then this implies what? That is, there exist integer s and t. There exist integers s and t. Okay, such that n is equal to A difference C and nt equal to B difference D. Okay, now what happened is here we also write about now, hence n is plus t equal to what? Equal to this one, E plus B difference C plus T. Okay, then what happened? And n divide this one. Okay, n divide this A plus B, n divide A plus B difference C plus D. Understood? Then what happened? Then we now talk about that here. Then that means this implies that A plus B here equal to C plus T with respect to modulo n. Understood? Then what happened? Then we talk about that. Then class A plus B equal to class C plus D. Then this implies that class with respect to modulo n is well defined. Is well defined. Understood? Not a problem at all. Okay, so now we're going to discussion about further. We now erase that portion and going to discussion about, that means plus, this one is plus with respect to modulo n is well defined. Now we define associative property. Okay, because we have to show that here this one Zn plus n be a commutative group. Understood? Zn plus n be a commutative group, we have to show that. So first we discuss about that this plus n with respect to modulo n, class with respect to modulo n is well defined. Now we erase that portion and going to further discussion of that. Okay, so we now erase that portion. and going to discussion about that this associative property hold. That means we also show that this one is plus modulo n is well defined. Okay, not a problem at all. Now we're going to discussion about that here for all class A, class B, class C belongs to Zn. Understood? Here class A plus class B plus class C equal to what? Equal to, we write about in this way here, A plus B, okay, plus C, and this implies that A plus B plus C. Understood? And again also write it in this way here, A plus B plus C. That means this class with respect to A class with respect to modulo n. We just talk about plus now. Okay, so this one equal to what happened? This one equal to A plus with respect to modulo n B plus C class, and this one equal to A plus B plus C. This implies what? This implies simply that, okay, this one is associative. Okay, not a problem at all. Then we find this one here, A plus with respect to modulo n B plus with respect to modulo n C equal to class A with respect to modulo n class B with respect to modulo n class C. Okay, here for all A B C belongs to n. Okay, we write it in this way. Then what happened? Hence class with respect to n is associative. Understood? Then we now going to discussion about that here. Okay, now 0 class belongs to Zn. Okay, and for all class A belongs to Zn, what happened now? Here A plus A0 equal to what? A plus 0 equal to class A equal to what? Equal to here 0 plus A equal to 0 addition modulo n A class A. Understood? I think not a problem at all. This shows that, this shows what? This shows that, okay, this shows that here 0 is the identity element, class 0 is the identity element. Understood? Not a problem at all. I think all are understood this one. Okay, now we're going to further discussion of that. That means we have to prove that each element is, that means have inverse, okay, unique inverse. So how we do this? We also write it in this way also for all. We write it in this way also here for all A belongs to class A belongs to Zn. Okay, we write it in this way that minus A class belongs to Zn. Understood? Then what happened? Then we write it in this way, class A plus class A modulo with respect to n minus A equal to 0. Okay, how this one becomes 0 so easily? We write it in this way, A plus minus A equal to 0 class. Okay, not a problem at all. Understood? And obviously this one equal to here minus e plus e, this one equal to minus e here plus e. Okay, not a problem at all. Understood? Then what happened? Then we also write it now, thus minus e class is the inverse of class E. Okay, so now we erase that portion and going to further discussion of that. So we write it in this way, this one, thus minus E class is the inverse of class E. Okay, now we're going to discussion of abelian or commutative property. Okay, that means how this one become a commutative group or abelian group. We write it in this way for all class A, B belongs to ZL. Okay, then what happened? We write it in this way here, A addition modulo B equal to A plus B equal to B plus A equal to B addition modulo in A. Understood? Then what happened? Then this one equal to, so class N is commutative. Okay, and then what happened? Then Zn plus N is a commutative group. Okay, understood? I think all are understood this one. Easily this one is discussed today. Okay, so if we give a particular example, then this one is better. If we write z2 plus, then what happens? Okay, z2 means contain this one class 0 plus 1. Understood? Then this one is easily we talk about that 0 plus 1 equal to 1. Understood? And here 1 plus 1 equal to 0. Okay, and another one here 0 plus 0 equal to 0 and 0 plus 1 equal to 1. Understood? Not a problem at all. Then we also discuss about that this one be a commutative group. Okay, so today I'll stop here. I think I'll understand about this example. Zn plus with respect to modulo n is a commutative group. Understood? So we also discuss this one easily. That means here we give this example of commutative group. Okay, so Zn plus n is a commutative group. Okay, not a problem at all. That means we also discuss easily, all I understand this one. I think if you get this type of video, please subscribe my channel. If you have any questions, comments, suggestions, write it in comment box. If you want to give like, please click on like option. So this one is easy example, but we have to know about that. So please see this video, that means from first to last, and obviously follow our all videos and see these videos and obviously learn some topics about mathematics. So today I'll stop here. Thank you.